This module is mainly for revision. We'll go through the rules of algebra that you should be familiar with. There's a MyMathLab homework set that'll be useful if you need to brush up on these fundamental ideas. We'll start with a bit of number theory. We can see how the different types of numbers were developed, or discovered if you like, through history. First counting numbers, then integers. Dividing one integer into another gives us rational numbers, that is, numbers that are ratios. Adding irrational numbers gives us real numbers. All these types of numbers were discovered by the Chinese, the Indians, Babylonians and Greek mathematicians between 2,000 and 3,000 years ago. If you've ever wondered why there are 60 minutes in an hour and 60 seconds in a minute, it's because the ancient Babylonians had a number system based on 60, not 10 like ours. Around the 16th century, complex numbers were discovered. These are numbers that involve the square root of 1. In economics, we'll stick to real numbers. The following slides go through these types of numbers in a little bit more detail. We have natural or counting numbers and integers. The idea of a real number line is important. In coming lectures, we'll be dealing with the real number line. Rational numbers are the ratios of two integers, but not all rational numbers can be represented as finite decimals, as we see here. Rational numbers don't fill the number line. An irrational number is a non-periodic infinite decimal fraction. Pi is a famous irrational number, as is the square root of 2. It's believed that the square root of 2 was the first irrational number discovered. This goes back to the ancient Greeks. Of course, you've heard of Pythagoras' theorem. A problem was the diagonal of a square with a side of 1. Legend has it that Hippasus of Metapontum discovered that the square root of 2 is an irrational number, and his fellow Pythagoreans weren't too happy about that solution. In Module 2, we briefly considered proofs by contradiction. The proof that the square root of 2 is not a rational number is an example. There's a video of the proof included in this module. If we think about operations on different types of numbers, that brings us to the idea of closure. If a particular operation is performed on a set of numbers and the answer is also in that set, then we say that the set has closure on that operation. For example, if we add natural numbers, we'll get a natural number. If we subtract one natural number from another, we may not get a natural number, but we will get an integer, and so on. Here's another way of summarising that. The rest of the slides in this module summarise the basic rules of algebra that you're expected to know. You can find more details in Chapter 2 of the 5th edition of our textbook, or Chapter 1 of the 4th edition. There's also the homework set I mentioned in MyMathLab. It'll be useful revision. The homework exercises also show you how to solve a problem if you're having trouble. We have the power rules. You should be familiar with these. Laws of addition and multiplication. Rules of operations for fractions. Fractional powers, we use those quite a bit, particularly in microeconomics. In the next module, we'll look at inequalities and psi diagrams.